Today, ladies and gentlemen, I'm going to refactor the code I have so far for my little text parser. Because, well, it's about time. I mean, just look at this. It's supposed to be a simple tokenizer, and it is. It only processes 2 types of tokens, but I wrote it and even I can't follow what it does anymore. So let me just go through it and make it a bit clearer. This part is just initialization, that's fine. Now, here's where the fun starts. The first if deals with text tokens, and the second if deals with assignment operators. This is for whitespace. Well, I guess that is pretty clear at least. And here I handle invalid characters. Okay, that's the general structure. When I look at tokenizing text, half of that code is error handling. And I know it's necessary, but error handling never makes your code more readable. I wish there were a way to specify error handling away from the happy path of your code. But there isn't, so I can make it less obtrusive though, and my goal is to make it clear that errors are handled, but to move the details out of the way. What I mean is, I want to keep the if because that shows the error I'm checking for, but everything in the body can just go into a separate function. Those are details I don't care about. I'll call the function handle too many tokens. Those break statements are a bit troublesome because of course I can't break out of this while loop by putting a break inside the function. Fortunately, in this case it's not a problem. Whatever happens in that function, I need to break anyway, so I can just put that here. Okay, I can replace break with return. This one can just go. Splendid. Oh, I'm missing the index here. Clearly I need to pass some arguments. I need current error. I need last error. And I need the index. Ah, wait. I'm changing current error. I mean, I'm changing the pointer. So I have the current error itself. And it's part of an array, but that's not something this function cares about. This function just wants to know which error to write to. Now, because the function wants to change the error, I need to pass it by pointer. Otherwise, the function would create a copy of the error, change that, and that would do no good because the error in the array wouldn't be affected. So I pass current error by pointer. If I use the pointer to make a change, I'm changing the error inside the array. Nothing new there. However, looking at the code, on the last line, I'm changing the pointer. Not the error it's pointing to, but the pointer itself. But the pointer in handle too many tokens is a copy of the pointer in tokenize. So changing it here doesn't affect the rest of the program, and I need current error to move forward for the entire program. So what I need is a pointer to a tokenize error. Inside handle too many tokens, this is current error. I need to dereference it if I want to have the same pointer as in tokenize. But now I can update that pointer from handle too many tokens. It's not hard to do, I mean, ta-da! But it's so finicky to use. Anywhere I was using current error, I now need to dereference it. And here I actually need brackets around it. It's easy enough to write, I suppose, if you just take it step by step. But in my experience, if you come back to this later, it's so hard to read and get a clear idea of what's happening. But for now, a double pointer does the job. Let's just pass in the arguments. We need the address of current error, of course, then last error, and index. Well, I do think that's an improvement. Can do the same thing for the assignment operator. I still have this check, and even though the error handling takes only one line, I would like to put that in a separate handle function too. That way it's explicit that there's error handling going on. So this will be handle too many tokenized errors, and I need the last error for that. And I can use that function here as well. That does look a lot better to me. Now it's clear which code does error handling and which code does, actual stuff. Let's run a quick test to see if I didn't break anything. Reduce the number of tokens. create a test case. I have tokens, I have errors, all good. You may have noticed that I use static arrays quite a bit. Arrays are the only collection type C has natively, so they are kind of an obvious starting point when you need a list of some sort. But I also like arrays because they keep you very close to the way memory actually works on a computer. It's just a long list of subsequent bytes, basically. And that happens to fit the use case of my text parser quite well, because I only need two things from my arrays. First, I want to add items to them one by one. Second, I want to iterate over those items. There's nothing in between either. I add all the items, then I iterate over them, that's it. I don't need any dynamic allocation for that. Basically, the only concern I have is how many items are there in the array. With a static array, I just reserve a bit of memory up front. That's not the actual size of the list I'm interested in. That's still 0. I just set a bit of memory aside. Every time I add an item, the size goes up by 1. Of course, the problem is, I might want to add more items than can fit in the memory I reserved, so every time I add an item, I need to check if it will fit. As long as I have the actual size and the maximum size, that's not hard to do. This also means that I don't need the sentinel anymore, because the sentinel is a special value that marks the end of the array. But if I have the size, I already know where the array ends. First, I'll tackle filling the array of tokens. I need to know where the array starts. I also need to know the maximum number of items I can put in the array. And then as I fill the array, I'll keep track of the actual number of items. By the way, size can of course never be negative, so I can make this unsigned. Actually, C has a special type for sizes like this, and it's called size T. For my platform, it's defined as unsigned long long. Well, long long basically means big as integer, so it's an unsigned integer. Now that I have the struct, I can initialize it in main. I don't have to initialize size. Anything I leave out will automatically be 0, so that's nice. Now, instead of passing the tokens to the tokenizer, I will pass my custom array, and I'm going to make changes to its size, so I need to pass it by pointer. Change that here as well. Currently, the code works under the assumption that the array is available and that I fill it by iterating over it. So, current token is always the next token that needs to be filled. Basically, it's always one ahead. I want to think about it a bit differently though. Instead of assuming the memory is already available, I want to allocate it for a token, then fill it. Allocate it, fill it. So instead of advancing to the next token after I initialize the current one, I will allocate a new token right before I fill it. The allocate function receives the array and can now increase the size. Then it has to return something. In this example, I have already allocated 3 items from a maximum of 6. When I call allocate, it increases the size by 1 and then returns the new item, which has index 3. So what I return is first plus size minus 1. Fix the return type. It's now also pretty simple to add a bounce check to the array. If the size is already at maximum, then I return a null pointer to indicate the problem. And then I can catch it here. Same change here. And I don't need this initialization anymore. I can do the same thing for the array of errors. I just copy the array code and change token to tokenize error. Of course, it would be nice to have something like generic types or templates right about now, but no, not in C. I could fix it with void pointers, but let's not go there. Copy-paste will do just fine. Initialize the array in main. Update the argument type. Update the formatting while I'm at it. Don't need this anymore. And then here, I allocate a new error from the array of errors. Check for null. Remove this. Of course, I don't have last error anymore, but I can pass the array. The function still needs last error, but it can find that by itself. I can now also update handle too many tokens, and the nice thing is, I don't need that double pointer anymore. I pass the array instead. Let's get rid of all the dereferencing. And this can go all together. And then allocate a new array. Check for null and pass the array. And that gets called here and here. Check if it still runs. Well, it does, but it doesn't give an error anymore, and that's because with the sentinel gone, those 4 tokens now actually fit in the array. If I add another token though, there's my error again. Good. Good, good, good. Of course, that creates a problem as well, because the parser was relying on that sentinel, and now it doesn't really know when to stop anymore. So here we get to part 2 of my plan, the iterator. The iterator keeps track of the current token, and it knows when to stop. Inside parse, I will replace current token with an iterator, and I can initialize it from the array of tokens. So of course, parse now needs to accept an array of tokens. And update main. Actually, I don't have to pass token array by pointer, because parse isn't going to make any changes to it. Let's just pass it by copy. And get rid of the arrows. Now, here's the problem I created by getting rid of the sentinel. When I'm parsing an assignment, I'm assuming, and you've heard this before, text assignment operator text. But what if I don't have that? What if I have text and then nothing, end of the array? With a sentinel this is fine, because if I ask, is this token of type assignment operator, then the answer is no, it's of type none. But without the sentinel, just asking the question means that I'm reading memory that's out of bounds. That's bad. Best case, it will crash immediately, but more likely it will blithely continue with whatever piece of random data it happens to find at that memory location. So what I will do is, I'll replace current token plus plus with a function call that advances the iterator and includes a bounds check. I'll call it like this, and if the iterator goes out of bounds, the function returns null. All I have to do then is check if I have a current token before using it. I know the check is a bit longer now, but it's also more explicit. You can clearly see that I'm handling the out of bounds case, so I'm fine with it. Advanced token takes an iterator, and it's going to make changes to it, so it needs to be a pointer. It returns a token. In the normal case, it moves to the next token and returns it. But if the iterator is already at the last token, it returns null instead. You may have noticed that I don't initialize current token anywhere, so let's do that. This is a bit of a problem though, because now I skip the first token. But that's an easy fix. I just return the token preceding current. That also means I need to change the check. It's fine if current points to the last token at the start of the function, it just can't exceed the last token. Alright, let's replace current token plus plus everywhere. And now I need to find all the places where current token is used and make sure I check if it exists, starting with the while. This is the old way of checking for the end of the array, so I can replace it. This check is already covered by the check in the while. This assignment is safe because of the if here. This if needs an extra check. That also covers this assignment, and this assignment, and this assignment. And this assignment is covered by the check in the while loop. And that's it. Let's up the number of tokens a bit and give it a test. Yep, that makes sense. I have one assignment, then the assignment starting with 2 fails because many isn't an assignment operator, and the assignment starting with many fails because there are no more tokens. So it's correct that token is a null pointer in that last error. That's pretty much what I had in mind regarding arrays and iterators, so let's apply those patterns throughout the code. The parser needs an assignment array and a parse error array, so I copy that code from the tokenizer. I also copy the error handling functions because they are pretty much the same as well. Replace tokenize error with parse error. And token with assignment. The only change that I need to make is that handle too many assignments doesn't get an index, but a token. Initialize the arrays in main. Pass them to parse. Update the parameter types. Get rid of all this. I like that, that's nice and clean. Let me quickly point out the structure of the parser, that should make things a bit easier. I either have an assignment or an invalid token. An assignment needs a key, an assignment operator, and a value. And when I have that, I create the assignment. Getting the value is now kind of in the wrong spot, but I can fix that with a temporary variable. Yep, I like that. This is where I need a new assignment, so I allocate it from the array of assignments. Then check for null and handle the error. I don't need this anymore. Then I have some errors I need to allocate. Check for null, handle error, remove this, copy, paste here, remove this, paste here, remove this. Splendid. There's one more thing though. Both the assignment operator and the value still have this error handling code when the token is of the wrong type. They're both pretty similar too, so I'd like to extract that into a separate function. Handle unexpected token type. It needs the array of errors, it needs the current token, and it also needs to know which error to report, because that's different between the assignment operator and the value. Change the break into return, and then I can call it. Oh, well, there's an interesting detail. If the token type is wrong, I continue, but if I'm out of errors, I break. Well, I can't replace the continue with a break, because I do want the loop to continue. What I could do though, I could check in the while if I'm out of errors. Like this. I'll just add that flag to the struct. By default it will be false, and then when I'm out of errors, I set the flag. That'll do it. Okay, now I can replace this. Here as well. But do be careful, because I still need that advanced token. I actually want to skip the current token. That should be it. Output is still the same. The memorizer needs an array for the entries and an iterator for the assignments. I'll just do that off screen because it's no different than what I already did for the parser. Here are the arrays and the error handling functions and the iterator. All set. Now the changes to the memorize function are also nothing new. There's one interesting bit though. At the end of the while loop I advanced the current assignment because, well, I want to go to the next assignment. But that means that I can also rewrite this as a for loop. I don't need to, but let's do it. Let's just see what that looks like. I like that actually, because to me a for loop just suggests that you're iterating over something, and that's exactly what I'm doing. In the parser it doesn't work so well because I advance the current token all over the place, but here it fits perfectly. But I think I can do a bit better still. That whole part with checking the buffer size, it isn't immediately clear what it does. So what if I take all of this, put it in a function. Let's see, I need current assignment, buffer index and buffer size, and then I want to return true if the key and value will fit in the buffer. I also spotted, and this is very important, that there is no space between the plus and the 1. Why? What was I thinking? Clearly this needs to be fixed. There, much better. Okay, now all of this can go, and this becomes a function call. See, that's much clearer. I like. One last thing is that I don't remember why I originally decided to return a copy of the settings. It contains the string buffer and the list of entries, so it's potentially quite large. All the other functions use an output parameter. I don't see why the memorizer can't do that as well. So create the settings in main, pass them to memorize. Actually, my convention is to list output parameters first, so memorize error array should be before ini. Might as well fix that. No more return value. Then I also need to fix the parameter list. The dot needs to be an arrow. Here too. Remove the return statement. That's it. A quick test, of course. Hey, color shouldn't be null. Ah, buffer full. Well, the error handling is working. Larger buffer. Problem solved. Almost there. Only the get function left to go. That one actually doesn't look so bad, but it still relies on a sentinel, so I need to fix that, which will require an entry iterator. And here it is. No surprises there. And then in the get function itself, I just create an entry iterator. Oh. Oh, no. Oh, man. Okay, yeah. Well, a bit of a surprise here. Normally, I would create the entry iterator from the entry array, but I don't have the entry array. All I have is settings, and that only contains a pointer to the first entry, but I also need the last. But I thought I was done. Ugh. Can I put the entry array in the settings? Well, I can make this an entry array. Not sure I'm gonna like this. So now I need a regular array of entries in main. But can I initialize it like this? I'll find out, I guess. I don't need this entry array anymore. This now needs to be settings.entries. Now I can create the entry iterator as usual. And I'll use the iterator in a for loop. Okay. Run? Yeah, that looks fine. That wasn't as hard as I thought it would be, to be honest. Cool. Well, that's enough refactoring for today. As far as I'm concerned, most of the functions are more readable now, but it does come at the expense of more initialization code. I'm happy with that trade-off, but you know, there are so many ways you can go with a refactoring like this. Just experiment and see what you like. That's quite enough for now, but next time I'm going to parse sections. So subscribe if you want to stay up to date. A big thank you to my Patreon supporters, you keep me going. See you next time, and remember, coding is fun.